Welcome back to the Power Shed. Today I'm doing some playing around with a LM393 comparator board. This comes with a little pot, 10K temperature sensor, and you got a 3-pin connection on it, VCC, ground, and output. And I got the schematic for it right here. What I'm doing is I have a chest fridge that's it's a freezer that's converted to a fridge, and these things aren't designed to run a long time. They're very inefficient if they run for long periods, and I think part of the reason is the motor is used as part of the thermal heat sink of the whole thing. I mean, it's a big mass of iron and you have to heat it up, and so it takes away some of the heat. And, you know, it sits down and it doesn't have any fan on it. The evaporator coils are on the skin of the freezer. And, you know, I don't think they're that great. But, you know, it's pretty good. But I'd like to cool down the motor. So I'm going to use this as a temperature sensor. And so what I have is, you know, let me just show you this working. I'll warm it up with my fingers. These are pretty sensitive, so it's running now. There's something you should see. See, the voltage is fairly low, and then it turns back on. This forms a bridge circuit, and so this voltage divider gets compared with this voltage divider. And these are very sensitive to changes in resistance, but not that sensitive to voltage changes. And you can see it. Changes quite a bit of voltage. But so anyways, this thing is designed for input to like an Arduino. It's, you know, 3.3 volts or 5 volts. And so they have, let me clear this out, a 1K resistor pull-up for the LED. Now, these you can operate at, I think you can get up 25 volts or something with these or more. And they would be a good driver for a FET. But this resistor, I got this set up at, you know, at about 10 volts. If I raise the voltage a little bit higher, enough to drive a FET. You'd get about 8 milliamps through this, and it's a, you know, teeny little resistor, 20th of a watt or something like that, and that's just about the limit. You know, you get 1.7 volts across that for, so they have to have this 10K pull-up to make sure it reads right with a microprocessor at 3.3 volts. There's no hysteresis, so it could be noisy. And I use just simple, from 12 volts, I can use a 1K resistor here. There's no reason to put a Zener in there. This voltage divider, so you got two 1Ks, and then you got to subtract out this, you know, 1.7 volts for the LED. And, of course, when it turns on, it's going to draw more current and drop down. But it works okay. So on the far end here, we're driving a fan with a PNP transistor, a little 10K to, you know, short out any little current that you might have, 2.2K. And I have an 8.2 volt Zener to create this offset voltage, so it, you know, totally turns off. Very simple, it works. Now, one thing you could do with this is, I was thinking, hey, could this be a little hot water heater? Sure, anything can. So it would be nice if you just pulled out the temperature sensor and monitored the voltage across this. So you could have a voltage divider. And if you lowered this resistance to, say, 1K, this 10K from the power supply would be insignificant. So, yeah, but you'd still have to solder these two leads on her. Cut the connector and wrap wires around it. But that's a interesting thing I'm going to try. But right now I'm just working on a refrigerator. So I got a new scope. Well, it's, come on, work you sucker. So you got multimeter, you got a signal generator, so you can generate all kind of waveforms. And of course, an oscilloscope. This says a 50K bandwidth. 50K bandwidth is not a 50K scope. This is a decent, you know, 10, 15 megahertz scope, maybe even 20. When you're sampling, waveforms can get kind of strange. The software's, you know, it's FinServ, and their stuff is always driven by marketing, not really people in technology, and so they are hopped up on goofy little features that would be in here, but don't make a lot of sense. But you know, I have a number of their products. This is a scope I got last year. Nice little pocket scope. This would fit in a pocket, but awfully big pocket. And when I was leaving, I could not find, see, it's a single input, and it says MDX or XMD, or, you know, I don't know what the connector is, but anyways, I couldn't find a scope probe, so I just came here, and then I was thinking, you know, I'll just buy a scope probe. But it was just cheaper to get another scope. So that's what I got. And it's kind of nice. It's a little goofy, but any kind of instrument, I don't trust any instrument. You know, something has to match what I think it'll do. And if it's different, you know, a meter will only tell you what it thinks it sees. But, you know, these are like $125, and for a signal generator, a really decent voltmeter, and a 2-channel scope that gets over 10 megahertz, that's a pretty good deal. You just got to be aware there's some goofy stuff in it. So that's what's happening at the shed. See you again.